Now let's try an example. If a solution containing 29.16 grams of barium chloride is mixed with a solution containing 15 grams of sulfuric acid, according to this reaction, let's try and find the limiting reagent. Now I don't need the question to tell me it's a limiting reagent, because immediately you should have alarm bells going off going ding, 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 ding. I've got too much information. So I need to find the moles. So I'm going to find the number of moles of barium chloride, which is equal to mass over formula mass. The number of moles was 29.16 divided by 208.2, which I've got off the periodic table, and that comes out to 0.140058 moles. Now I'm going to store that information on my calculator. The number of moles of sulfuric acid, we do the same way, mass over formula mass. The mass was 15 grams divided by the formula mass, which is 98.086, and it comes out to 0.152993 moles. Now, the easiest way to do this is to just try one out. So I'm going to try out barium chloride. So what I'm going to try and do is find out how many moles of sulfuric acid are required if I use up every bit of this moles of barium chloride. So I go, the number of moles of sulfuric would be equal to unknown over known times the number of moles of barium chloride in this case. So going to my equation, it's 1 over 1. So 1 over 1 times 0.140058, which is 0.140058 moles. Now I need to ask myself a question. Do I actually have 0.140058 moles of sulfuric acid? So I go back to what I actually have. This is the actual quantity I've got. And you can see, looking at this is much larger than this number here. So this is telling me that I've in fact got plenty of sulfuric acid. And the limiting reagent, which is the one that runs out first, will be the barium chloride. So now we're up to part B. Calculate the mass of the precipitate. So our known must be the limiting reagent. So our known is the barium chloride and our unknown is the barium sulfate. So going back to our balanced chemical equations, the number of moles of barium sulfate, will equal unknown over known times the number of moles of barium chloride, which was our limiting reagent. Going back to our stoichiometric ratio, the known is barium chloride, which is 1. The unknown was barium sulfate, which is also 1. So it'll be 1 over 1 times 0.140058, which is 0.140058 moles. Now, like any stoichiometry, the next step would be now to find the mass of the unknown. So the mass of the barium sulfate will equal number of moles times formula mass, which equals 0.140058 times the formula mass of barium sulfate, which is 233.3, which comes out to 32.69 grams. Now, going back to the original question, you can see we had 4 significant figures there and 4 significant figures there. So our answer must also be in 4 significant figures. Let's do part C. Now in part C it says determine the mass of the unreacted reagent. Well, our unreacted reagent, the one in excess, is sulfuric acid. So in order to find out how much sulfuric acid is in excess, we need to know exactly how much sulfuric acid was used before we can do that. So we go the number of moles of sulfuric acid used in the reaction will equal unknown over known times the number of moles of barium chloride. So going back to our ratio, 1 over 1 times 0.140058. So the answer is 0.140058 moles. So how do we do this? So we go the number of moles of sulfuric acid in excess will equal the number of moles of sulfuric acid at the start minus the number of moles of sulfuric acid used. So this will equal, how much did we have at the start? 0.15293 minus the 0.140058, and this comes out to 0.01287 moles. Now we can find the mass of the sulfuric acid. So the mass of the sulfuric acid in excess is equal to number of moles times formula mass, which is 0.01287, times the formula mass, which we calculated earlier, 98.086, which equals 1.26 grams. 2 grams, because remember we have to have 4 significant figures.